Hello everyone, this is Mr. Regner, and this is our Chapter 8 or Topic 8 Assessment Practice. You can follow along with me on page 375 in your book. And just a reminder for you, this video may be kind of long. The purpose is not necessarily to watch the entire video from beginning to end, but instead to kind of help yourself out. So as I answer questions, I'm going to mark them with questions like here. We'll start with question number 1. You can kind of skip ahead in the video and go to the questions that you need to look at or questions that you're not sure of. Or if you'd like, you can watch the whole thing and watch all 15 questions. So let's get started with number 1. It says, which rectangle has the greater area? A rectangle with a length of 1/12 foot and a width of 3/4 foot, or a rectangle with a length of 1/16 foot and a width of 4/5 foot? Whoa, okay. So I've got two rectangles here. I'm going to kind of recreate these rectangles here on my page with some poorly drawn rectangles, apparently. So we have a length of 1/12 foot and a width of 3/4 foot, I think, for the first one. That's 1/12 and 3/4. The second one is 1/16 and 4/5. All right, so I need to know my area formula. And I know that area equals base times height, or base times height, length times width, right? That's the same formula I can use for both of these. So basically, I want to find the area of each rectangle and then compare and see which one is the greater, which one has the greater area. So let's go ahead and plug in some numbers. My area is base times height. That's 3/4 times 1/12. And then over here, my area is 4/5. Because I could have done 1 and 1/16. So let me get to work. Now here I could think about cross-simplifying. 4 and 1, that's not going to work out, but 3 and 12, yes. Because 3 goes into 3 once, and 3 goes into 12 4 times. If I multiply straight across, 1 times 1 is 1, 4 times 4 is 16. On this side, I can cross-simplify, not 5 and 1, but 4 and 16. 4 goes into 4 once, and 4 goes into 16 4 times. Now multiply straight across. 1 times 1 is 1, and 5 times 4 is 20. So this is 1/16, and I guess I should say that would be square feet. And this would be square feet as well. We have 1/16 square foot and 1/20 square foot. Now we got to think which one's the bigger area, right? Fractions can be kind of tough to think about, so I always think about pizza. If I have a pizza and I cut it into 16 slices, and I have another pizza, same size, cut it into 20 slices, which piece is going to be the biggest, right? The one that has 16 pieces or the one that has 20? Well, if there's 20 pieces, they got to be smaller pieces if they're cut out of that same whole pizza. So 1/16 is going to be the bigger area. It's the bigger fraction. That's going to be the rectangle with the greatest area. Let me move on and let's take a look at number 2. Let's see if I can get this into the video screen. Here's number 2. It says Alberto runs 3 1/4 miles each day. It says N total miles, and there's 3 1/4 listed there 1, 2, 3, 4, 5, 6, 7 times. So part A says write an equation using the variable N to model how far he runs in 7 days. Well, that's no problem, right? We can just take 3 1/4. That's how much he runs in 1 day. He's going to run 7 days, so times 7, and that will equal the total number of miles he's going to run. Now, there's some variations on this. I could have done 7 times 3 1/4 equals N, right? I could have set up a division problem, but this is probably the most obvious equation for this one. Letter B says, how far does he run in 7 days? Okay, so basically for letter B, I have to solve this problem. 3 1/4 times 7. So I'm going to take 3 1/4 and turn it into an improper fraction. I'm going to do that by taking 4 times 3 and then add 1. 4 times 3 is 12 plus 1 is 13. That's my new numerator, and the denominator stays the same. So I've taken 3 1/4, turned it into 13/4 because they're the same. It's just an improper fraction version of that mixed number. Next, I'm going to take 7 and turn that into an improper fraction by just putting it over 1. 7 over 1. and now I can multiply. Now I might think about cross-simplifying, but in this case, I can't do it. There's nothing to cross-simplify. So I have 13 times 7, which I don't know what that is. Let me just do that off to the side here really quickly. We can always do math if we need to. 3 times 7 is 21, and 7 times 1 is 7, plus 2 is 9. We get 91. That's 91. And then 4 times 1, well, I do know that one. That's 4. Whoop, whoop, whoop. Improper fraction right here. 91 fourths. We want to turn that back into a mixed number by dividing. So I have 91 fourths. Think of that as 91 divided by 4. I'll set up my division problem over here so we can see it. 4 goes into 9 2 whole times. 2 times 4 is 8. I'll subtract and get 1. I'll bring down my 1. 4 goes into 11. Well, not quite 3 times because that'd be 12, so only twice. 2 times 4 is 8. I'll subtract. 11 minus 8 gives me 3. And that remainder becomes my new numerator. So I just take my denominator, right? Take my remainder, bring that back up here. The remainder is the numerator. The divisor is my denominator. I end up with 22 3/4. So I get 22 3/4 miles. Because again, we're talking about Alberto running miles. So I guess I can label that miles. I hope I have enough room on the page here for part C. It says, explain how to estimate how far he would run in 11 days. All right, no problem. So for this, we want to explain how far he'd run in 11 days. If he's running 3 1/4 mile, right, in 1 day, we can estimate that. For that, I'd probably round 3 1/4 to just 3. And then I'd multiply 3 times 11 to get 33 miles. And I could explain that I've estimated the total miles he runs in 1 day by rounding 3 1/4 down to 3. That is number 2. Let's move on to number 3. It says, is the following equation true? And explain. Okay, well, I think I can do that. So it says 5 6 times 8/4 equals 5/3. Well, that is a whole bunch of stuff I don't understand, so I need to write it down. And I encourage you to write it down on your own page, even as you're working on the test, right? So we can check it out. Now, they've written 5/3. That's their answer, right? I may actually write this down without the answer and just see if I get the same answer. So I'm going to do that here. 5 6 times 8/4. And let's just see what answer I come up with. So I might think about cross-simplifying. 5 and 4, that's not going to work out. They don't have any common factors. But 6 and 8 do have a common factor of 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. That's going to make things a little bit simpler, right? So 5 times 4 is 20, and 3 times 4 is 12. Well, let's see. 20/12. Can I simplify that down at all? Do they have any common factors? Yes, they do. In fact, look, 2 goes into 20, and 2 goes into 12, right? But wait a minute, I wonder if there's anything bigger than that. Let's see. 4 goes into 20 5 times, and 4 goes into 12 3 times. I could divide this by that form of 1, just simplifying it down. That form of 1 could be 4/4. 20 divided by 4 is 5, and 12 divided by 4 is 3. I get 5/3, and look, that was my answer up here. So I could say for number 3, yes, that is a true equation, and I can explain it with my math down here. Let's move on and take a look now at number 4. Move my page up. Number 4 says, complete the equation and show your work. No problem, right? It's a 16 times 5/8. Just multiplying a whole number times a fraction. Now remember, we can turn our whole number into a fraction by just putting it over 1. Now we've got a fraction times a fraction. We can multiply straight across, but I like the idea of cross-simplifying to make my life easier, so I'm going to do that. 1 and 5 I can't simplify because I already have a 1. Can't simplify 1 down anymore. It's as simple as I can get. So let me look at 8 and 16. Ooh, 8 and 16 have a common factor of 8. Right, so 8 divided by 8 is 1, and 16 divided by 8 is 2. That's going to make this so much simpler. Now when I multiply straight across, 2 times 5 is 10. 1 times 1 is 1. And of course, 10 over 1 is equal to 10 whole. That's the whole number. That's number 4. Let me go ahead and take a look at number 5. Now, number 5, there's maybe a couple of strategies you can use here to help yourself out. We see here that there are 5 different options. It says select all of the expressions that are equal to 4/7 times 6. Well, in order to answer this question, I'm actually going to solve that. 4/7 times 6. I'm going to make that 6 over 1 right away because I know 6 is equal to 6 over 1. Think about cross-simplifying, but we quickly find out we can't. So let me multiply. 4 times 6 is 24, and 7 times 1 is 7. I get 24/7. Whoop, whoop. Improper, right? We're going to turn that into a mixed number by taking 24 divided by 7. 24 doesn't go into 2, but it goes into 24 3 times. 3 times 7 is 21. I subtract and I get a 3. Take my divisor, take my remainder. They come together to become the new fraction part here. So I get 3 and 3/7. Fantastic. Now, it didn't really ask me to solve that, but again, I think I kind of need to in order to answer this question. So look at option 1. It says 4 divided by 6 times 7 equals 14/3. Well, let's see. 14/3. I'm going to write that down. 14/3. It's improper. Let's just see what happens if I take 14 divided by 3 and turn this into a mixed number. 3 goes into 14. We'll say 4 times. That would be 12. I'll subtract. I get 2. That'd be 4 and 2/3. Is 4 and 2/3 the same as 3 and 3/7? No. So option 1 is a no. Option 2, it says 6/7. That looks weird on my screen. I don't know if it's on yours too, but that should be a fraction. 6/7 times 4 equals 24/7. Guys, look, 24/7. Huh? Yeah, 6/7 times 4. Now look what they did here. They switched around the 4 and the 6 like my numerators. They made it 6/7 times 4. It works out because we know we can multiply 4 times 6 and get 24, or 6 times 4 and get 24. Turns out that is correct. So option 2 would be correct. I'd mark that one yes. For the next one, we have 6 divided by 4 times 7. They got 10.5. 10.5 is not close to our answer, so we'd say no. The next one, this is the 4th one now. 4 times 6 divided by 7. They got 3 and 3/7. Hey, that number sounds familiar. That would be a big fat yes for me. And finally, the last one, 7 divided by 4 times 6 equals 21/2. Let's see, 21/2. I'm going to solve that one again. Over here, I can think 21 divided by 2. 2 goes into 21 4 times. That'd be 20. I'd have a 1 left over. That's 4.5, which of course is not the same as 3 and 3/7. So I'd say no. So looking at this, my correct answers would be, let's see, make sure I've got them right here. The second one and the 4th one. So I guess it'd be like options 2 and 4, if you're looking at it that way. All right, let's move on to number 6. Get a new page here. Number 6 is a word problem that we must read, and perhaps maybe read it more than once, if needed. It says Tracy took a test that had 24 questions. She got 5/6 of the questions correct. How many questions did she answer correctly? Write an equation to model your work. All right, so let's think about this. She got 5/6 of the 24 questions correct. Remember, of means times. Lock that phrase in your brain. So we're saying that she got 5/6 of the 24 correct. That's 5/6 of times the 24. So there's our expression, 5/6 times 24. Right now, we just solved that. I'm going to take 24 and put it over 1 because I know that's what I can do with any whole number to make it a fraction. I can think cross-simplify. 5 and 1, not going to happen. The 1 is as small as it can get. How about the 6 and 24? Hey, wait a minute. I think I'm onto something here. 6 goes into 24. So 6 divided by 6 is 1, and 24 divided by 6 would be 4. Now I multiply. 5 times 4 is 20. 1 times 1 is 1. 20 over 1 equals 20. And to put a label on here, we could say that Tracy answered 20 questions correctly. There you have it. That's number 6. Let me move on now to number 7. Let's see here. Flip my page up here a little bit. On number 7, it says Jenna ran 2 7/8 kilometers each day for a week. How far did she run in all? Give an estimate and then find the actual amount. So guys, this kind of reminds me of question number 1. Was that number 1? I think it was. No, number 2, where we had that was Alberto running before for 7 days. Now we've got Jenna running. It's 2 7/8 miles per day. You got to think, how many miles are there? Or how many days are there in a week? That would be 7. We're multiplying her amount of miles run in one day times 7 for 7 days. Now it also asks us for an estimate. So if I were to estimate this, I take 2 7/8 and round that. So I got to think, am I rounding up or am I going to round down? 7/8 is really close to 8/8. So I know I'm going to round this up to 3. So my estimate, I'll just say, is 3 times 7, which is 21 miles. We can guess that she's going to run 21 miles. That's our estimate. Not exact, though. Let's get the exact number right now. So 2 7/8, I want to turn that into an improper fraction. So I multiply 8 times 2 is 16, and then 16 plus 7. We got 23. 16, I think I said 16 plus 7. 23. We'll keep the denominator the same. So 2 7/8 is the same as 23/8. We're going to multiply it. Here it comes again. Okay, I think I'm okay. We're going to multiply it 7, but I can turn that into a fraction. Just turn it into 7 over 1. So now I'm going to multiply 23 times 7 and 8 times 1. I could think about cross-simplifying, but it turns out I can't do that here. 1 is already 1, and 8 and 7 don't have any common factors. So 23 times 7, I don't know what that is, but I can figure it out mathematically. I've got this brain power going. 3 times 7 is 21, and 7 times 2 is 14, plus 2 is 16. That's 161, or 161. And then 8 times 1 is 8. So now I have an improper fraction. Whoop, whoop, whoop. Alarms are going off. I need to turn that improper fraction into a mixed number, and I do that by dividing. So I'm going to take 161 and divide by 8. So 8 goes into 16 2 whole times. 2 times 8 is 16. I subtract and get a 0, bring down my 1. 8 goes into 1 0 times. I'd subtract and still get a 1 as my remainder. So I get 20 1/8. And I'll go ahead and say miles. So Jenna ran actually 20 1/8 miles. Our estimate was 21, so we know we're pretty close there. So we have a pretty legitimate answer. That is number 7. Let's move on and take a look now at number 8. Number 8 says, Eduardo has a recipe that uses 2/3 cups of flour for each batch. If he makes 4 batches, how many cups of flour will he need? How many cups of flour will he need in total if he makes 3 more batches? Write your answers as mixed numbers and use the number line to help. So the number line here is great. You can use that to help you, obviously. We could do repeated addition, or we can just multiply like we know how to do. So we know the recipe calls for 2/3 cups of flour, and he makes 4 batches. So I might look at this and just think I'm going to go 2/3 times 4, right? Now, if I choose to use the number line, I could figure out where 2/3 is, and then add up 2 more thirds, and 2 more thirds, and just multiply times 4. So I can make this 4 over 1. I can try to cross-simplify, but I won't get too far, because I can't. 2 times 4 is 8, and 3 times 1 is 3. I get 8/3. If I turn that into a mixed number, I want to take 8 divided by 3. Since 3 goes into 8 2 whole times, right? 2 times 3 is 6. I'd have a remainder of 2, and the denominator stays the same. That means that we're going to need 2 2/3 cups of flour for 4 batches. Okay, no problem there. Now that second part said, whoa, wait a minute. How many cups will he need if he makes 3 more batches? Now, since I've done it this way, I can just add 3 more to 4, right? and have 7. Do the same thing. 2/3 times 7. I'll make it 7 over 1. I can't cross simplify. 2 times 7 is 14, and 3 times 1 is 3. I can again turn that improper fraction into a mixed number. 3 goes into 14, we'll say 4 times, right? 3 times 4 is 12. And then that would leave me with 2 left over. I get 4 2/3 cups for 7 batches. Now, I've shown you this way. Again, I think some of you will be kind of used to this idea. We've done it so much. If you want to use the number line, though, let me just show you what that might look like. Now, I'm going to try to recreate this in a very poor way. I just know it. That's not too bad, I guess. All right, that's not very good, but you get the idea. So what I can do here is, and I'll just use a highlighter here just so you can see in different color. I can find 2/3. That's right here. That's 2/3. That's one batch, right? 1 2/3. I can go 2 more thirds for another batch. 1 2/3. That's a second batch. 1 2. That's a third batch. 1 2. That's a fourth batch. That fourth batch, by the way, if you look at it, it is at 2 and, oh, did I mess that up? 2/3, right? Yeah. 2 2/3 is right here. 2 2/3. And if I would have been able to extend that, I could have added on 3 more batches and figured out my answer would have been 4 2/3. So the number line's not a bad way to go. I'm not discouraging that by any means, but maybe it might be easier for you if you're thinking just multiplying whole numbers and fractions. You could do it that way. Let's move on to number 9. Number 9 says, complete the equation and explain how you got your answer. All right. So we have 6/7 times 2/5. So let me complete this, right? We can't cross simplify, so I'll just multiply it straight across. 6 times 2 is 12. 7 times 5 is 35. I get 12 35ths. I always want to think, can I cross simplify? And in this case, I think about 12 and 35. Or can I simplify? 12 and 35, do they have any common factors? I think 12, that doesn't go into 35. 6 times 2, does 6 go into 35? Ooh, wait a minute. No, that won't work. No. Okay, what about 2? 2, no, that doesn't work either. Let's see, 4, no, that doesn't work. Maybe 3, no, that doesn't work. That's as simple as we can get, right? So number 9, kind of an easy one. The big part there is going to be the explanation to explain that you're multiplying numerator times numerator, denominator times denominator. Let's move on to number 10. It says Ted and his friends are rolling out clay for art class. Ted rolled out his clay until it was 2 feet long. Noah rolled out his clay 3/5 as long as Ted's clay. Janine rolled out her clay until it was 1.5 times as long as Ted's clay. And Miles rolled out his clay 5/5 as long as Ted's clay. What? Now, just to make sense of this, I think it may help you to have a little bit of a chart here, right? So we know we have Ted. Ted's rolled out his clay to be 2 feet long, right? And then we have Noah. Noah's clay is 3/5 as long. So that's 2 times 3/5. And then we had Janine. I don't want to spell Janine's name wrong, but I probably will. There you go. Oh, you can't even read that anyway. My handwriting's so poor. So again, we're taking Ted's length, 2, and Janine's is 1.5 times as long as Ted's. And then finally, Miles. Good old Miles. I wonder how he's doing these days. So 2, because that's Ted's, and his was 5/5 as long as Ted's. So there's 3 parts to this question. Part A, it says, without completing the multiplication, whose clay is longer than Ted's clay? Well, let's check it out. I should probably move this up so you can see that a little better. So Ted's clay is here. Remember, if I multiply anything by a number less than 1, it shrinks down, it scales down. By something greater than 1, it scales up, it grows. And by something equal to 1, it stays the same. So without even doing any math, I know that Janine's clay is longer. I didn't do any math there. Isn't that amazing? Now, what's kind of fun about this is it says without doing the multiplication. Guys, you probably could do the multiplication if you want to just verify your answer. For letter B, it says without completing the multiplication, whose clay is shorter? All right, no problem. Again, I'm multiplying by a number less than 1, so Noah. Noah's clay is shorter because I'm multiplying by a number less than 1. And then finally, letter C, you knew this was coming. Whose clay is the same length as Ted's clay? Miles's clay is the same. And we know it's the same because we're multiplying by 5/5, which is just a form of 1. That is number 10. Let's move on to number 11. Number 11 says find the product of 7/8 and 9/10. All right, I can do that. It says then write another product with the same answer. Okay. So first, let's solve this one. We can think about cross-simplifying, but we can't. 7 times 9 is 63, and 8 times 10 is 80. I get 63 over 80. I can think about cross-simplifying here, simplifying, but they don't have any common factors. That's my answer. It says write another product with the same answer. And some of you will be baffled by this. You're going to be like, I can't do it. There's no way. Check this out. 9/10 times 7/8 equals 63 over 80. Look, all I did is I used the commutative property. I switched them around. Right? That was super, super easy. So try not to make it more difficult than it has to be. Just come up with another product by switching them around. Easy. Let's move on to number 12. On number 12, it says, which of the following is equal to 4/7 times 11/15? I feel like we've seen something like this before. Oops. And so last time, if you remember, I just solved that. 4/7 times 11/15. And then I looked at my multiple choice options to see which ones were equal. So think about cross-simplifying, but we can't do it. 4 times 11 is 44, and 7 times 15, all right, 105. Okay, 105. Now, you may not have that memorized. You may need to solve that off to the side, and that's fine. We get 44 over 105. If we take a look at our options, letter A says 28 over 165. Nope. Letter B says 60 over 77. Nope. Letter C says 44 over 105. Hey. And letter D says 105 over 44. Nope. So letter C is our correct answer for number 12. Let's move on to number 13. Number 13 says members of a landscaping company built a retaining wall. They used brick to make the top 2/3 of the wall. Of the wall. Remember, of means times. I'll write that down again. Of means times. So 2/3 of the top, right, is brick. So we're taking 2/3 of times the height, right? So 2 3/4 is that top. So to multiply this, I want to turn my improper fraction into my mixed number into an improper fraction. You can tell it's late at night, right? So 4 times 2 is 8. 8 plus 3 is 11. This is really going to say 2/3 times 11/4, because 2 3/4 is equal to 11/4, right? So now I can cross-simplify if I can. I see a 2 and a 4. They have a common factor of 2. 2 divided by 2 is 1. 4 divided by 2 is not 1, but 2. There we go. Now I can multiply. 1 times 11 is 11, and 3 times 2 is 6. I still have an improper fraction. I want to turn that into a mixed number. 11/6, I can think about dividing. 6 goes into 11 only one time, and I'd have 5 left over. So I get 1 5/6. Now, I didn't really do a good job here of showing this one because I just went right to the problem. But let's look at letters A, B, and C here. Letter A says, what is the height of the brick portion of the wall? Well, there's the height, 1 5/6 feet. So I guess we can call that letter A. Letter B says, estimate the area of the whole retaining wall. All right, no problem. We know for letter B, and I'm kind of writing that over here, area equals base times height. And if we're estimating here, we're going to take 2 3/4, and I'm going to round that up to 3. And then 8 1/2, I'm going to round that up to 9. So 3 times 9 is 27. And I'll say square feet there, because it is square feet. We're going to move on to letter C. All right, so in letter C, it's asking us for the actual area. So let's see here if I can give myself some space. Part C, we're going to use area equals base times height, but I'm not estimating this time. I'm using the real numbers. So I have 8 1/2 times 2 3/4. Right? So in order to multiply these numbers, there's a couple different methods, but a lot of you seem to enjoy the idea of using improper fractions. So that's what I'm going to do. I'm going to multiply 2 times 8 plus 1. 2 times 8 is 16, plus 1 is 17. That's 17 halves. And then over here, I'm going to multiply 4 times 2 plus 3. 4 times 2 is 8, and 8 plus 3 is 11. We get 11/4. So my area is 17 halves times 11/4. I can think cross-simplifying, but I can't do it. So I need to multiply 17 times 11. Not sure what that is. Let me just multiply that over here. 1 times 7 is 7. 1 times 1 is 1. Add a placeholder 0. 1 times 7 is 7. 1 times 1 is 1. Add them together. I get 7, 8, 1. That's 187. And then 2 times 4, a little easier. I know that's going to be 8. So I have 187 divided by 8. So I need to divide because that's obviously an improper fraction. 187 divided by 8. 8 goes into 18 2 times. 2 times 8 is 16. I subtract and get 2. Bring down my 7. 8 goes into 27 3 times. 3 times 8 is 24. And 7 minus 4 is 3. 2 minus 2 is nothing. So I'm going to take my divisor. That becomes my dividend. The remainder becomes my numerator. I get 23 3/8. The area equals 23 3/8 feet squared. Now it says to compare that to our estimate. So just to remind you, our estimate before was 27 feet squared. So our actual estimate was way higher. We overestimated there, and that's because we rounded our numbers. So that kind of makes sense for me. So yeah, we can say that is a reasonable answer. Let's move on to number 14. We're now on the last page here of this practice test, which is good news. So number 14, here it comes. It says, Tyler's family rented 15 DVDs last month. It gives you those blue circles, which maybe helps you to see, but there's 15 of them. So there you go. Letter A says, of the 15 DVDs, 1/5 were documentaries. How many of the movies were documentaries? It says use the model to help you. So we can definitely use the model if we'd like, but we're seeing that word of. Of means times, right? So 1/5 of the 15. 1/5 of times the 15. Remember, 15 can become 15 over 1. I can cross simplify. 5 goes into 1 once, and 5 goes into 15 3 times. 1 times 3 is 3, and 1 times 1 is 1. That means 3 documentaries. 3 of those 15 movies were documentaries. In letter B, it says 3/5 of the movies were comedies. So 3/5 times 15 over 1. Again, 5 goes into 5 once, and 5 goes into 15 3 times. 3 times 3 is 9. 1 times 1 is 1. That's 9 comedies. 9 of those movies are comedies. In letter C, it says, what relationship do you notice? So this is kind of a tricky one because you got to really look at the numbers. We have 3 documentaries, 9 comedies. Maybe with the model, you might be able to see it as well, or maybe easier. But just think, what's the relationship here? Think about it, 3 and 9. 3 times 3 equals 9. There's 3 times more comedies than there are documentaries. Or can kind of look at it the other way and say there's 1/3 as many documentaries as there are comedies. So for part C, you'll want to just explain that relationship. Finally, moving on to number 15. Number 15 says, Kristen and Nico buy a canvas for their art studio. It says estimate the area. So you can see the drawing there. It's 2 1/2 and 3 1/4. That's a horrible canvas. I am not an art student like Kristen and Nico are clearly, so I should probably stick with math. Anyway, so for letter A, it says estimate the area. All right, so no problem. We know area is going to equal base times height. If we're multiplying base times height and I'm estimating, I'm going to estimate my numbers. 2 1/2, I'll probably round that up to 3. And 3 1/4, I will round that down to 3. Area estimated is 3 times 3, which is 9 square feet. That's my estimate. That was letter A. I should have mentioned that. Moving on to letter B, it says find the actual area. All right, let me do that. So letter B, the actual area equals base times height. My base is 2 1/2. My height is 3 1/4. I'm going to find the actual area here by taking these mixed numbers and turn them into improper fractions. So 2 times 2 plus 1. 2 times 2 is 4 plus 1 is 5. I get 5 halves. Over here, take 4 times 3 plus 1. 4 times 3 is 12 plus 1 is 13. I get 13/4. I've just taken the mixed numbers and turned them into improper fractions. Now I think about cross-simplifying, but I can't. So I just multiply straight across. 5 times 13. This is the way I kind of think of it, and maybe this will help you as well. I think 5 times 10 is 50, and then 5 times 3 is 15, so I get 65. 2 times 4 is 8. I get 65/8, but that's clearly an improper fraction that I want to turn into a mixed number by dividing. So I'll take 65 divided by 8. 8 goes into 6? Nope, it doesn't. 8 goes into 65? Well, yes, it does. 8 times 8 is 64. It goes in 8 times. That's 64. I subtract and get 1. Use my divisor. Use my remainder. It becomes my new fraction. I get 8 1/8 square feet. Letter C says compare your answer to your estimate to see if your answer is reasonable. And my answer for the estimate was 9 square feet. My real answer is 8 1/8 square feet. So yeah, that's pretty reasonable, pretty close. And that, my friends, is the practice assessment. Now, we've seen this a lot before. The practice assessment kind of matches up with the types of questions we're going to see on the test. So use this video, review it, maybe skim through, maybe go to the questions you're not sure of to help yourself out. If you have any questions, always feel free to contact me as well. Have a fantastic day, and I hope you do your best on the test.